Okay, so hello everyone. My name is Roy. I'm very excited to be here. Thank you very much for attending. And I'm going to talk to you about machine learning. So let's start. Well, we're going to see 3 different applications of a technology that is called machine learning. I'm going to tell you a little bit about what it means and how we used it. The first one is going to be from the video editing domain. This is this Obama over there. After that, about missile defense, I'll explain why. And then user acquisition, which I'll refer to as UA from now on. I hope that's okay. So before we start, I want to show you a couple of videos. One of them is real and one of them is fake. And I know you need to move your hands and it'll be hard, but I want you to engage a little bit and tell me which one of these are real and which one is fake. Okay? Are you ready?
In words.
Especially our friends who are lesbian, gay, bisexual, or transgender. I visited with the families of many of the victims on Thursday.
Okay, so please raise your hand if you think the right one, your right-hand side, is the real one. This is this one? Yeah, right. And the other one? Okay, that worked better in previous times, but cool, cool, cool. That's also good. And you're right, actually, this is the fake one. Sorry, this is the fake one. This is the real one. And it's important to say that although it didn't fool most of you, you're probably very, very talented and sharp-eyed people. But, but usually, and I want to illustrate that these videos were created solely by a machine learning algorithm. No manual editing of the lips or anything like that was done here, okay? So how was it done? Basically, the algorithm was trained using 14 hours of data of Obama videos, of Obama giving lectures and whatever. And the algorithm learned, found similarities across videos, found patterns, found modifications that are relevant, that look good, and then it applied the audio line onto the video, onto the target video, and then created the fake video. And just to show you, and I hope these will fool you a little bit, but how robust and how amazing this technology can be. So basically you can take any target video and you can take any audio sample of Obama. Both should be of Obama, but with some modifications it can be applied to anything. And this is something you can make.
To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs. Not to mention the job training that helps folks earn new skills to fill those jobs.
Okay, so as I said before, all of this was done without a manual editing, no video or any After Effects kind of work here, just like this. So this is the first example of application of machine learning in the video editing domain. Now, the next one is going to be about missile defense. I just want to tell you a little bit about myself. In my previous job, I served for 4 years in the Israel military, in the cybersecurity units. And along the way, we've dealt with various challenges. One of them was trying to help build the algorithms behind a missile defense system, okay? And this is what I'm going to talk about now. And we used machine learning, that's the key. So as you can see here, before I start, missile defense system must know what kind of missile, what type of missile the system is targeting, okay? Various missiles, as you can see, look differently, behave differently. They have different sizes and altitudes and diameter and what we call drag, or the friction with air. And because it's very, very different, the system must know what it's targeting. So that's the challenge here. The challenge is to try and classify what type of missile it is using the data. Now, what is the data? The data we used is a very simple location data of the location of the missile in space while it's flying, okay? So it's only X, Y, and Z coordinates of the missile in its flight. Now, I know this is not very clear, so we used our very talented creative team to build the next illustration to show you exactly how the missile flies on this diagram. Are you ready? Yeah, like this. Okay, so that's basically what we have. It's a very, very kind of poor data, not much details, not a lot of features, what we called. But still, the idea is to try and classify the missile. How can this be done? So the algorithm takes these dots and create the whole trajectory, the whole path of the missile in the air. in order to kind of try and predict how it's going to look. And now that the algorithm created these trajectories or the whole path, it can say, okay, the larger missiles fly higher, the smaller missiles fly sharper, and a lot of kind of similarities, patterns, stuff like that. And using these kind of insights, the algorithm can predict what type of missile the system is now targeting, and this is the goal. Does this make sense so far? Excellent. So basically, the two main principles of machine learning, you don't tell the model how to work. You give it a lot of data, it trains, and then it gives predictions. And everything can be done very, very, very fast and very accurately. This example of missiles, this system or similar systems can save thousands or millions of lives using the ability to make predictions very, very fast and very, very accurately. How is this related to user acquisition? So we covered these two pretty fast. Now, before I show you what we did with user acquisition and how we did it, I want to tell you a little like what I mean by user acquisition, because if you ask 5 people, you'll get 10 different answers, I guess. So basically, as I see it at least, user acquisition has 2 base parameters. You need to have a very good creative, a kind of video or an ad or an image that will take your user to say, that's nice, I want more of this, I want to click, I want to buy, I want to go forward and do whatever you want they to do, sorry. And you need some technology. You need technology in order to have a full insight of the funnel. You need to know what is going on before the install and after the install. You need to track results, you need to optimize results, etc. So you need to have all this kind of infrastructure in order to start. Once you have that, you just need to throw your ads to different channels and optimize it. And that can be done using Google AdWords, an amazing platform, Facebook or Pinterest, Twitter, whatever you like, any social platform out there. Various media buyings, a lot of representatives of them are here. And also search engine optimization and app store optimization, the new kind of buzzing word. Can you see that? Okay, now you can see it. So app store optimization, and surprisingly enough, this is exactly how yellowHEAD, the company I come from, is built. We have a very strong creative in-house studio. We have a tech team. And we have different departments that manage each of these channels. Now, regarding App Store optimization, we actually have the biggest or the most successful App Store optimization department in the world. We're covering apps like Tinder and Airbnb. And we even do the App Store optimization. You can come in, guys, if you're like crowded there. Or not. We're doing the Google app in Play Store, which is kind of awesome because they can't do it because of like policy or stuff. I don't know. So now I want to tell you what we do regarding machine learning and user acquisition. And in order to do so, I'll use a little better video that we made, and I'm going to introduce you to Allison.
What if you could know exactly how your campaign is going to perform? Well, they know. It's not just our kick-ass UA experts' amazing creative studio or our fully managed solution. Meet Allison, yellowHEAD's groundbreaking predictive mastermind, engineered by top university math professors specializing in machine learning. Allison analyzes dozens of parameters and draws actionable conclusions. Based on millions of data points with advanced statistical model, she will predict your campaign performance, allowing us to optimize faster and better to get you greater results. Stop wasting your ad spend. yellowHEAD.
Sorry, did you see the missile? We have something with missiles in. Yep, no. So how is Allison so good, and how, and as I'm going to show you? Well, first thing, the big advantage that a machine learning algorithm has on a human being is the ability to look at much more parameters. The person before me just talked on how many parameters you need to see, you need to optimize accordingly. You have a whole forest of parameters in his example. And so basically, this is a short list of what usually a campaign manager looks at when they try to optimize a campaign. So you have the amount of spend you had, and the CPI, the cost per install, and the FTD, not everyone calls it like this, but this is the first time depositor, or the first, the amount of users that did any deposits in the app, and ROI, and not a very long list, but usually that's enough. Allison looks at this. As you see, it's not only that Allison looks at more more parameters, it also looks at the greater level of detail per each parameter. If you look at ROI, and that's what most people look at, so Allison can look at the ROI after 1 day of install, 2, 3, 4, 5, 6, etc., and various chunks of ROI and stuff like that, and that kind of gives Allison the insights or the ability to cover and give more information when it gives its prediction. Now, before I move forward, I'll summarize Allison in one sentence. Allison has the ability to take our data, a lot of data. We have in our database 2 years of tracked data, something like $10 million of ad spend from what we gathered along the years. And Allison predicts the ROI D7, or the future return on investment of a certain ad in 7 days' time. Let's say you're opening an ad today, you'll wait a day or something to see how it's working, and tomorrow you'll be able to know how the ROI is going to look with great level of accuracy in 7 days' time. Does this make sense? I hope so. Great, I see nodding faces. So how we build Allison, okay? Allison is looking at this, but how we started and how we realized that this is what we need to look. So basically the first part, when you have that much data, is to try and analyze it. Not a very simple task. Usually things are not very clean as you want it to be, but with a lot of work and a lot of process, we've managed to find some great analysis, and we did a lot of analysis, so I'm going to show you very quickly a few. So this one is kind of an illustration, a plot of month and day of the week to see how weekends during the summer look a little different and stuff. This one shows, okay, it's a bit tricky, what percentage of ROI is being deposited in each day after the install. As you can see, after the first day, roughly 30% is being accumulated or already deposited. Okay. And then it drops, and each app and each account has a slightly different curve like this. And knowing that has a lot of importance when you try to predict the future. This one shows various bins of installs and how they behave according to frequency and mean cost and stuff like that. This one. Okay, this one is one I really like. This one, it was kind of a aha moment for us. This one shows the correlation between CPI, cost per acquisition over here, and the ROI. And you can see that when you have low CPI, when your CPI is still kind of low, when you'll grow your CPI, when you'll pay more for each install, your ROI is going to increase. Okay, that makes sense, as in you'll get better quality users, your users will be more valuable, they'll deposit more, and although they cost more, they'll be more valuable. And that works up to a point. But from that point on, you're paying too much for your users, and although they might be a little bit better, they're not good enough to improve your total ROI. That means that your ROI decreases. So, to summarize, this graph shows that when you grow and grow your CPI, in the beginning it's actually a good thing to do. It will increase your ROI, but after a certain point, it will start dropping. And knowing what this point is, or what is your optimum CPI, is very, very valuable. And we know that for each app, and that helps us find better results. And Allison obviously knows that and better predicts the future. So this is just a few examples. Now, this is the interesting part, the results, or what Allison can do. This graph is from the last month. I've obviously hidden the names of the app we manage. But you can see that it's a bit tricky, so I'll explain what we see here. If a certain account spends $1 million a month, okay? Allison tried and predicted every day for the next week what will be the ROI. And you can see here that in most apps, or on average, we're in about 80% accuracy. Allison predicts 80% accurate with 80% accuracy the future ROI of current ad campaigns today. Think of the significance this kind of information will have. Now this is cool, and we were very happy when we produced this graph. And then we said, okay, that's not enough. Why isn't that enough? Because two reasons. First of all, maybe that's not very high. Maybe our account manager give 85% accuracy in their decisions. So 82 is nice, it's great. Perhaps it's better than some competitors, but it's not good enough. That's one reason. And the second reason, maybe we're testing Allison on a very, very, very kind of stable month. Machine learning algorithms like stability. So if this week will look as the next week and the one after, Allison it will be easier to kind of predict what will be the future. Just go with the line and it will probably be the same. So that wasn't good enough. So we started thinking, okay, how can we really isolate Allison's contribution to our campaigns? How can we measure how good Allison is or how much it improves us? And then we started thinking, okay, an account manager or a campaign manager takes dozens or hundreds of decisions every day. They can increase the ad spend for a specific ad. They can open a new audience or change an audience. They can change the creative. They can increase the bids or reduce the bids, et cetera, et cetera, et cetera. Hundreds of decisions. So we started calculating which of these decisions, looking retroactively, were correct and which were wrong, which should have been taken and which shouldn't. Okay? And now we got to a certain number. For each app, we know what is the rate of correct decisions that is being made. Now, obviously, a more experienced campaign manager has less error rate and so on. But what we wanted to see is how Allison changes this. Okay? What is the difference between an account manager without Allison and with Allison? And this is this graph. It's normalized to 100%. This is the blue, green, whatever color you see. This one's is what account managers did before, or the rate of correct decisions made by account manager before they used Allison, or in apps that don't use Allison for a certain reason. And in the orange, you can see that in some apps, first of all, in all apps, Allison improves the rate of correct decision, which is wonderful, because then there's no reason whatsoever not to use Allison. And the second part is that you can see that in several apps, Allison almost doubled the rate of correct decisions. That means that when an account manager thought, I think this ad is not going to perform very, very well, I think I'll close it. And Allison told him, no, don't, keep it, it's awesome, just wait, have some patience. And the account manager did that. That was right. The ROI of that ad a week later was great. And to the other side around, okay? I hope this all makes sense. So basically, we covered machine learning in video editing, and we've seen how similarities can produce cool and a little bit creepy results. We've seen how in missile defense, this technology can be applied very, very, very fast and very accurately. And we've seen how user acquisition, we can dramatically improve the ability of our professional team, of our account managers, in order to produce higher results, better results. Thank you very much. And you can all meet us at booth 117 to hear more about all of this and more.
Well, thank you very much.
Thank you very much. Thank you.
We could probably sneak in one quick question if anyone has it. Anyone want to do the one quick question? I will ask a quick question if not. I noticed you've got your apps, ABC, etc.
Yeah.
For both charts, were they the same app? So was app A the same app in both slides?
Well, it wasn't intentional, but I think I sorted it by the name, so I think it is. But I'm not 100% sure.
The only reason I asked is because I noticed the one that had the least impact from Allison had actually the lower kind of retention, lower kind of uplift, lower ROI.
Yeah, that only makes sense. Yeah.
Cool.
I haven't tested it, but yeah, that makes sense.
Just thought it was interesting. Okay, thank you very much.